Hello, everyone, and welcome to the webcast. My name is Christine Dorsey-Davis. I'm the Executive Director of the Ohio Chapter of the American Planning Association, and I'm your webcast moderator. Today, we will hear the presentation, Advanced Air Mobility, Integrating the Third Dimension into Metropolitan Transportation Systems. For technical help during today's webcast, you can type your questions in the chat box found in your GoToWebinar tool panel. And for your content questions related to the presentation, again, just type those in the chat box in your GoToWebinar tool panel. We will answer those at the end of the presentation during the Q&A. If your question is for a particular panelist, I just ask that you state their name somewhere within the question so I know who to direct that question to. Coming up next on your screen is a list of our sponsoring APA chapters and divisions for 2020. Thanks to all of those participating sponsors for making these webcasts possible and free to members. Coming up next on your screen is actually a screenshot of our webcast webpage. Head over to ohioplanning.org/planningwebcast. There is where you can register for all of our upcoming sessions. We are booked every Friday that I'm available through the end of the year. We're also now hosting some Wednesdays and Thursdays. We might have a couple Tuesdays in there. So be sure that when you're registering, you take a look at those dates because they're not all Fridays. Like I said, this is a screenshot of our webcast webpage. There's a couple tabs up at the top. Prior webcast tabs, that's where we post PDF copies of all of our presentations. We also have some distance education sessions available on demand for viewing and for credit through the end of this year. We have, I think, 2 ethics, a law, and a general session. So be sure to check those out if you need those credits or if you're interested in those topics. So again, head over to ohioplanning.org/planningwebcast to register for our upcoming sessions. Today's session has been approved for 1.5 CM credits. For live viewing, head over to planning.org and log into your MyAPA account. And from there, you can either search by today's title or event number to log your AICP CM credits. If you didn't get a chance to write the number down or don't remember the title, again, just head over to our webcast webpage and you can get all that information to log those credits. And make sure you like us on Facebook. That's where we post any immediate information, like new sessions that are available to register, or if we have a date or time change, we're going to post that stuff there. And be sure to click the red button, subscribe to our YouTube channel. We record all of our sessions, and this session, along with over 300 other sessions, are up on our YouTube channel. So be sure to subscribe to us so you get notifications when things are posted, and you will be among over 3,000 subscribing friends. So with that, I'm done with my housekeeping items, and I am going to turn it over to Yolanka, who will kick us off today. Yolanka Wolf, I have sent the controls over to you.
Thank you. I'll just switch over to my screen here. And with any luck, you now see my presentation screen. I'll just verify with you, Christine.
Yes, it looks great. Thank you.
Thank you. Well, good morning from the West Coast. Good afternoon if you're on the East Coast, or good evening if you're somewhere else in the world. I am Yolanka Wolf, Co-Executive Director of the Community Air Mobility Initiative, or CAMI. CAMI's pleased to bring you today's webinar on advanced air mobility, integrating the third dimension into metropolitan transportation systems. Here's our agenda for today for the webinar. After a few brief introductions, our presenters will cover 5 topics. What is advanced air mobility? Planning for urban air mobility, understanding infrastructure considerations, understanding airspace considerations, and understanding the integration challenge. And then we'll follow that with some Q&As. While my co-executive director and I each have over a decade of experience in the electric aviation industry, CAMI itself is relatively new. We were founded last year and we're a virtual organization operating globally. CAMI was created to broaden the conversation and support local communities with advanced air mobility integration. We're a 501c3 nonprofit, which educates and equips state and local decision makers, planners, and the public with the information they need to set policies and design infrastructure and systems that address transportation needs for their communities. CAMI also brings the concerns of these communities back to the advanced air mobility industry to help that industry chart the right course for success. Today, we have a great panel of experts to provide content for the webinar. I'll introduce them all now, and then we'll dive into the material. At the end of the webinar, there'll be a slide with contact information for all the presenters. So I told you I was the co-executive director. My other executive director, my other co is Anna Dietrich. I'll just tell you a little bit more about myself. So before joining CAMI, I was a sustainable aviation consultant for over 10 years, working with industry, government, academia, and nonprofits on policy, standards, regulations, industry development, market challenges, communications, and media relations. I'm also a business attorney and consultant with experience in sustainable transportation and land use and nonprofit management. After I speak, you'll hear from Adam Cohen. Adam is a senior research manager with Transportation Sustainability Research Center at UC Berkeley. Since 2004, his research has focused on innovative mobility strategies such as urban air mobility, shared mobility, last mile delivery, vehicle automation, smart cities, and other emerging technologies. He recently completed 2 studies of the opportunities and challenges of urban air mobility for NASA and a manufacturer. Following Adam is Daryl Swanson. Daryl explores the infrastructure requirements of electric aircraft, including fixed wing and electric vertical takeoff and landing. He has over 20 years experience in airport master planning, capital planning, acquisition, due diligence, aerodrome safeguarding, as well as operating an airport in Africa. Daryl has established himself as a subject matter expert regarding electric aviation and how it will lead to a future of distributed aviation. Next up is Basil Yap. Basil is a nationally recognized leader, consultant, and engineer with over 13 years of professional experience in aviation. Basil started his career working in the highway transportation sector and then transitioned to airport development. He helped stand up and ultimately lead North Carolina's award-winning unmanned aircraft system program, both as a public servant and as an embedded consultant. And in 2016, Basil started the consulting firm HoveCon. And last but not least is Todd Peterson. Todd is a serial entrepreneur with a background in technology, aviation, and automotive industries. He's passionate about the momentous technological changes occurring in transportation in cities and advocates for open source technologies that both empower cities and create opportunities for the private sector. He identifies potential solutions to managing public spaces, including streets, sidewalks, and curbs, and challenges with operating drones and air taxis within urban airspace. So, moving on, I will now kick off the content with an introduction to advanced air mobility. We are in the third revolution of flight. The first was powered flight, ushered in by the Wright brothers. The second was the development of the jet engine. And now technology drivers such as the electrification of propulsion, autonomy, and mobility as a service are once again redefining flight. This allows us to lower costs and barriers to the use of small aircraft on shorter routes and increases the latent demand for flight as a viable alternative to ground transportation. Advanced air mobility, or AAM, is one of the most commonly used terms for this new form of flight. The development of new aircraft allows us to look at new use cases and to improve existing use cases. Urban air mobility, or UAM, is often used interchangeably with AAM. We tend to use it to focus on the shorter distance urban use cases, and we also use the term regional air mobility, or RAM, for the longer distances. Both are subsets of AAM, and as I say within the industry, you'll hear those terms used sometimes interchangeably. While the terminology is still developing, what is clear is that there are multiple zones of operations for AAM. These include connections within urban centers and also connecting urban economic centers to hub airports, suburbs, edge cities, and rural areas. These operations can exist in multiple forms, including micro-haul airlines with scheduled service, a bus route style air metro service, on-demand service, airport shuttles, and perhaps most importantly for early adoption, emergency services and goods delivery. This is the view of aviation most people are familiar with today up at the top. There's a strict boundary between your daily life and your flight. And while we have to maintain security and safety in AAM operations, to be successful, we have to at least figuratively tear down the fence. AAM will be intimately integrated with existing transportation systems, including highways and transit options. And we need to do that integration in a way that doesn't create a whole host of new problems. So doing that integration correctly is really a local question. To date, most of the aviation industry level regulatory and policy discussions have been happening at the federal level. We need to be working towards a constructive and consistent local policy and regulatory landscape as well. And that means engaging all of the stakeholders. So who are those stakeholders? You'll see many of them here. As you can see, they range from industry members such as manufacturers, operators, and airports, regulators at the federal, state, and local levels, agencies such as transportation and commerce, business owners, real estate developers, essential services, the public, and of course, planners. CAMI exists to bridge these stakeholders and provide opportunities for education, communication, and collaboration. So while the industry is making great progress in the technology development of these aircraft, we hear time and again that the biggest challenge to implementation is public acceptance. There are 4 critical factors that must be addressed to achieve public acceptance of advanced air mobility as a transportation option: safety, public benefits, limited adverse impacts, and integration. Safety, of course, is critical and non-negotiable. Commercial aviation has a strong safety record. However, AAM will scale to a level more akin to automobiles, and it isn't easy to determine what is safe enough. While it's primarily up to regulators like the FAA to answer that question, we also have to consider the public perception of safety, which comes from trust. Earning that trust is key to public acceptance. So it's essential to public acceptance that we're able to demonstrate public benefits early on. One of the first questions we often get is whether urban air vehicles are just limos for the very rich. And the answer is no. Advanced air mobility uses the third dimension to provide commercial, economically viable transportation for the public. These benefits include increased transportation options, socioeconomic benefits, workforce development, and of course, emergency services. Advanced air mobility has the potential to bring broad availability at a reasonable price to the public and a new mode of travel to metropolitan transportation systems. All of these benefits, of course, in effect mitigating factors against the inevitable negative impacts that AAM will bring. To achieve public acceptance, we need to limit those adverse impacts. And this begins with transparency about these impacts, which include noise, visual pollution, emissions, battery life cycle challenges, impact on electricity capacity, and impact on existing modes of public transportation. To enable the maximum benefit from AAM, it needs to be integrated with the existing transportation landscape within a community. Vertiports need to be strategically located to integrate with transportation hubs, such as light rail stations and airports. AAM has to take accessibility and equity considerations into account. And AAM also needs to integrate in a constructive way with existing transit. And finally, it needs to integrate with and augment existing goods delivery modes. So are cities and metropolitan regions prepared for this new form of transportation? AAM technology is moving forward rapidly, but transportation planning has a 10 to 20-year horizon. Are metropolitan planning organizations incorporating the third dimension into their plans? What about airports? Are utilities aware of the electric grid capacity needs that this form of transportation will require? Are departments of commerce thinking about the effects on workforce development? While we are still years away from a fully built out advanced air mobility system, we're also years out when it comes to planning for the system. And with that, it's now my pleasure to turn over the presentation to Adam Cohen, who will talk about planning for urban air mobility.
Thank you, Yolanka, and thank you to APA for the hosting this webinar and for the invitation to speak. Next slide.
Oops.
There we go. Okay, terrific. So first, I'd like to start out with kind of an overview of kind of what planners really need to know. Talk about some on-demand aviation use cases, introduction to kind of understanding community integration, a little bit more about potential concerns with UAM and kind of the role that planners have in mitigating those. I think Yolanka did a great job at the beginning, kind of talking about this at a very high level. I'd also like to kind of talk about the role of the built environment, which is really crucial to advanced and urban air mobility, long-range planning considerations, the role of the complete trip in first and last mile access, and how we can kind of develop mobility hubs. And then finally conclude with some infrastructure questions that Daryl is going to talk a little bit more about. Next slide. So some key questions that I think are really important for planners to ask are, what is urban air mobility or advanced air mobility, and what are the use cases? What are the kinds of concerns? Who, what, and how is UAM and AAM regulated? What types of tools can planners use to kind of guide this mode in their communities? How does the built environment impact it? And what are some planning and implementation considerations, and how can planners help? Next slide. So a little bit about kind of some on-demand aviation use cases. UAM and AAM really kind of includes a broad ecosystem of passenger mobility, goods delivery, emergency response, and other use cases using a variety of both manned and unmanned aircraft. You'll hear the term unmanned aircraft used even in the context if there's passengers on board. It really kind of refers to no pilot being on board the aircraft. As of March of this year, there were 12 operational passenger helicopter services globally providing on-demand service. This excludes any sort of prearranged charter services. And more than 250 vertical takeoff and land aircraft and electric rotorcraft were currently under development. As of 2018, the market was valued at $5 billion US, with a potential growth in the goods delivery and passenger mobility sector of up to approximately $3 billion at the low end by 2030. Several studies that were conducted pre-COVID estimate profitability for passenger mobility and goods delivery in the late 2020s and early 2030s. However, again, these studies were really done pre-COVID, and they're based on a lot of assumptions about technological developments that have yet to be realized. Next slide. So it's really important to kind of understand that historically, aviation and local communities have really kind of operated more or less in relatively distinct silos with unique stakeholders. Aviation, being kind of federal government, port authorities, air carriers, tenants, employees, and in some cases, the communities impacted either in the immediate airport vicinity or along the approach paths. And kind of local communities have also operated in distinct realms, really kind of, with local governments, your urban planners, transportation engineers, public transit, and all the other community stakeholders. And what urban air mobility, as well as unmanned aircraft systems or drones, does is it really kind of decentralizes, the impacts of aviation, and in a way that we haven't really seen before. And so really kind of the most important thing I can convey to kind of planners is this real kind of center point in this Venn diagram here of the overlap between the two. It's really kind of important to understand where these two worlds converge and how these very different stakeholders can kind of work together to overcome some key challenges. Next slide. It's really important to kind of understand that there are a number of potential concerns associated with this kind of on-demand aviation marketplace. Everything from safety, such as new aircraft designs, concerns about electric range anxiety, both from the perspective of users as well as people on the ground. A lot of concern potentially with some technological developments associated with either remote piloted or autonomous operations. As Yolanda mentioned, equity, accessibility, and affordability of these modes is really important, as well as concerns of visual and noise pollution. The figure on the left is from Mexico City a few years ago, in which Uber was using drones to advertise Uber Pool over freeways. There's also some concern about privacy and increased air traffic over residential areas, as well as the impacts of vertiports on neighborhoods. I'm going to touch briefly on some of these and in the context that planners, the tools that planners have that might be able to help address and overcome some of these. Next slide. So one of the things that our team did was co-author one of two market studies commissioned by NASA on urban air mobility. Now, it's very hard to survey future users of the services to really understand how they might use it, because they don't really have any interaction with existing electric vertical takeoff and land aircraft. However, these early exploratory study really provides some kind of key insight, I think, into what we can expect as the UAM and AAM marketplace evolve. This study conducted a 5-city survey of approximately 1,800 people, and it generally found neutral to positive reactions to the kind of concept of on-demand aviation, but real obstacles related to public perception of fully autonomous aircraft, concerns about how much these services would cost, a lot of concerns about personal security and safety, everything from being on board with another passenger that they don't know in a confined space, to concerns about sabotage and other types of incidents. There was also a concern expressed about privacy, in particular people flying over residential land uses, sight lines into yards, and potential for increased noise levels. So it's really kind of important to understand that these types of concerns could impact UAM both from a user as well as a non-user perspective, and it's really important for planners to kind of keep this in mind. Next slide. Now, Basil's going to talk a lot about airspace, so I'm not going to get very detailed into it, but this is a figure from the FAA Urban Air Mobility Concept of Operations, and broadly speaking, what the FAA, what their latest thinking is that they're going to establish basically corridors for urban air mobility and advanced air mobility to operate in that is below commercial traffic but above drone traffic or UAS. And so that's kind of what this depicts. So as I kind of talk about kind of AAM and UAM and kind of the role planners play, I just want you to kind of keep in mind kind of the type of airspace that we're talking about generally and how this might impact the local community. Next slide. Now, I am an urban planner by trade, and I will tell you that context in the built environment matters, and it's probably the most important thing I could possibly convey. This is a figure that we have developed for the U.S. Department of Transportation, really kind of categorizing U.S. communities into 5 different types of built environments in the U.S. And it's really important as we start talking about kind of the role that planners play and the role that this strategy might play. how we develop strategies and policies in each of these different urban contexts, both at a built environment scale, but also at a regional scale, such as small and rural communities, auto-oriented megaregions, as well as transit-oriented megaregions. Next slide. So a few key issues that planners should consider is, how is UAM and AAM defined in local policies and ordinances? How should rights of way be designed and preserved? And when I say rights of way, this both includes everything from curb space at vertiports or skyports, as well as the airspace access approaching it. This is where planners have a lot of tools in their toolbox, such as height limitations on land uses, for example. Should there be policy differentiation between use cases such as emergency response, goods delivery, and passenger mobility? Should we prioritize this in our urban policies and plans? How do we manage competition among multiple service providers for vertiport access? This is very much the question that we've had over the past 20 years with car sharing, bike sharing, scooter sharing, and others, is how do we manage competition among providers? What type of public sector investment, if any, should there be in these facilities? And how do we value, from a monetary standpoint, vertiport access? And how do we address a variety of administrative issues, such as insurance, liability, signage, first and last mile access, and many others? Next slide. So the public and private sector really can work together to understand, how this aviation strategy could fit within the transportation ecosystem, really working to identify and mitigate the impacts of urban air mobility, and really kind of consider, since we're talking about a 10 to 15-year time horizon, now is really the point that we should be considering inclusion into long-range policies and plans, everything such as general and comprehensive plans, and in the future, drilling down more into community and specific plans as well. Considering including, UAM into multimodal capital projects, and kind of beginning the discussion of how we adapt infrastructure for UAM to ensure that it's multimodal and oriented around public transportation. So some of the tools that planners have at their disposal, and this is not by any means an exhaustive list, but really kind of incorporating these strategies into kind of planning and visioning documents, soliciting community feedback through existing community engagement strategies, incentives, form-based codes, overlay zoning, permitting, and code enforcement are all many tools that could come into play in terms of how we integrate, particularly the vertiports, into our built environment. Next slide. So I briefly just want to kind of mention that as we kind of talk about the planning for UAM, it's really important to kind of think about the complete trip from the moment that the user kind of books the trip on their phone, how they connect to UAM, what types of connections are needed, and arrival at their destination. Next slide. So it's really important that we kind of start to plan to kind of develop what I call kind of UAM or AAM mobility hubs. These are really kind of the convergence of shared modes, public transportation, automated vehicles, last mile delivery, and UAM and drones and UAS into a consolidated facility where these interactions can take place. These facilities can also be supported through other services such as EV charging and AV parking and staging areas. But they can also be multimodal and mixed-use facilities with amenities such as dining and retail, fitness, residential, hospitality, retail, and other types of land uses. And as we kind of talk about these, mobility hubs, it's really important that we kind of think about kind of the core, kind of the zone around it, and the broader catchment area that UAM will be drawing upon. Next slide. Other planning considerations that are really important that I think that kind of planners kind of keep in mind is really kind of airspace access, to these facilities. Aircraft parking, how large these facilities have to be. The impacts of these facilities on the energy infrastructure in terms of battery charging or battery swapping. facility security, and how do we make these facilities secure but not intrusive into the surrounding built environment? And how do we make them kind of open access to accommodate a variety of aircraft types, operators, and users? Next slide. So while I would love to kind of keep on going with a lot of information, you know, I only have a limited amount of time here, but I will say that there are some infrastructure questions that I would encourage kind of planners to consider as we kind of talk about advanced and urban air mobility, really kind of drilling down into, you know, the built environment that we're trying to serve. Are we building or repurposing new infrastructure? You know, there's a lot of proposals to kind of repurpose things like parking structures for urban air mobility, as well as shared facilities for things like electric vehicle charging, as well as autonomous vehicles. What types of land uses and infrastructure need to be repurposed, you know, or adapted for UAM? The first and last mile connections. It's really important that as we kind of develop these facilities, that we prioritize public transportation, pooled vehicles, and active modes as well. So really kind of designing both the infrastructure to these facilities as well as policies that support kind of the prioritization of this type of access. Really kind of considering how we integrate UAM into nearby land uses, and how are we going to leverage planning tools to mitigate and discourage the adverse impacts that could potentially arise from this new and certainly disruptive mode of transportation. So with that being said, you know, I'd like to again thank APA for the opportunity to speak, and I will pass it over to Daryl, who's going to talk a little bit more about infrastructure in greater detail. Thank you.
Right, that's brilliant. Thank you very much for that. I'm Daryl Swanson. I'm going to try and share my screen as much as I possibly can. Right, what are we seeing here?
We just need you to put it in presentation mode. Whoop,
And how's that?
It just went away.
Right. There we are, show my screen. And there we go. How's that?
That's perfect. Thank you, Daryl.
Brilliant. Okay, so I'm Daryl. I'm an aviation consultant. Started my career planning and designing airports. Went on to help a lot of people buy airports, and then got involved in the electric aviation game. Around about the same time that Uber Elevated really came along, but just prior to that, when I was doing my MBA, I decided that I would take a look at buying an aircraft carrier and floating it south of London City Airport. I'm based in the UK, and turning it into a heliport. And that's when I really learned how much Londoners hate helicopters because of the noise and the lack of social amenities associated with the services that they can provide. So I've been waiting for years for Airwolf to come along with their super quiet operations, but they didn't. But we now have electric aviation, and I'm going to start us off looking at something which is coming back to the why of electric aviation. So this is the economics of hydrocarbon versus the economics of electric aviation, and this applies both to fixed wing, eCTOL, and eSTOL aircraft. So that's electric short takeoff and landing, or electric conventional takeoff and landing, and then of course eVTOL. So as we know, hydrocarbons have a huge amount of energy in them, so 43 megajoules per kilogram. So that means that the engines are incredibly complex, because effectively they're operating at temperatures above their melting point. So that means that they have high capital costs and high maintenance costs. In fact, when most aircraft engines are sold, they're not really sold, they're kind of long-term lease, but they're sold with a maintenance plan with them. Again, this makes everything expensive. But they're only about 24% efficient in turning that chemical energy into kinetic energy, and the rest is heat and noise, and that's something that you certainly hear about. The operating economics of it, because they are quite large, means that the aircraft have to fly over long ranges at high altitudes, and this just makes aircraft large. And of course, what that really means is that you need large aircraft and large airports to process enough passengers to pay for the infrastructure. And that's why airports are large. It all comes down to so much energy being available in hydrocarbons that everything just naturally grosses up in size. Where right now, the battery technology, depending on who you're talking to, is sufficient for eSTOL operations at 650 nautical miles with 10 passengers, or 130 nautical miles for 4 passengers. And of course, we have hybrid options that are coming to the market. But electric motors, we effectively have one moving part, so you have much lower operating capital and maintenance costs of these vehicles. And they're 94% efficient at extracting that stored energy into kinetic energy. And what that means is that there are more small airfields, which are closer to passengers' origins and destinations, than large airports with great surface access. So what that really means is that today's regional and GA airports will be tomorrow's sub-regional hubs. And then, of course, we add on vertiports, making that connection. Now, what I'd like to do now is take you through, hopefully you're still seeing my screen. So this slide is put out by Lufthansa Innovation Hub, and what we're really looking at is this transportation leaderboard. So what we're highlighting here is the fixed-wing electric aircraft, which have ranges up, say, to 1,000 kilometers. But we have this natural connection with eVTOL operations. So there's that natural link. And so what we might see is that some of these airfields, which are on the peripheries of your cities, they'll have passengers coming in from the longer range, transferring onto eVTOL, and then they'll be linking in to our city centers. And really, we're talking about this micromobility because we're trying to get passengers as close as we possibly can to where they actually want to go. But then, of course, we have public transport that we can rely on. And as much as possible, any applications that you see need to be utilizing that public transportation mode as much as possible to try and get passengers off of single user taxi rides. So in terms of a series of vertiport types, of course, we're going to have our small existing airfields. So all the infrastructure is there for them. You'll have questions to ask about how they're getting passengers to and from. So what's the road transport impact of that? We'll have dedicated regional and urban vertiports. So this is a concept of a vertiport at an existing airport in Cambridge in the United Kingdom. This concept here is on the back of St. Pancras Station. So this is our large commercial vertiport operations. And then I'm predicting that we're going to see these support type vertiports. And at these facilities, they may be exchanging electrons for a bit of package delivery, or you might have what we call MRO, maintenance, repair, and overhaul type operations. But in terms of the city port or city vertiport concept, capacity is key because these are commercial facilities. They need the volume of passengers, they need the volume of traffic through them to make them financially viable. But because of that, location is incredibly important. But again, it's not about competition with public transport, it's about complementing it. So we really need to make sure that we're doing our best to minimize the impact on the local road network. And about social acceptance. And of course, we're going to get that through demonstrating a significant social utility in terms of more society being able to access that service through commoditization, and that's where the capacity issue comes in. And then also the low noise impact, so making sure that the location of these things takes into account noise sensitive communities. So if it looks like I'm reading, it is because this is relatively fresh off the press, but we need to start with a plan. So being an airport planner, I like to start with a system plan. So we really need to take a look at the entire region that you're looking at. So if I was doing a system plan for London, I would have to take a look at all the London airports to make sure that we're taking in all the issues. So we need to identify the existing aviation assets, both VTOL and CTOL, what's going on there. You have to have a good understanding of how electric aviation can enhance or hinder the movement of people and goods within your city. You'll have to compare large vertiport concepts against smaller vertiport concepts. This whole idea of on-demand, I'm not necessarily a big fan of on-demand electric aviation for the fact that it just means that you need so many vehicles and so many vertiports that you're really approaching that Jetsons, and I'm not quite sure whether or not society is ready for that. We'll have to take a look at what the high volume vertiports impacting on transportation networks. So it's either a redistribution and congestion reduction, or it's a concentration leading to insufficient capacity at peaks. And what are the airspace restrictions? Of course, we've had some good chat there from Adam, and I know that Basil's going to talk about that in a lot more detail. And then eventually we're going to come to a point when automation really starts to come in, and automation really takes the brakes off of what you're able to do in some of these vertiports, but there are going to be natural limits to that. So what does the infrastructure needed? We need a very good public transportation system, of course, and I think we should build it all on the back of a good public transportation system. I think we need to really accept those micro modes of transportation, and you need that supporting infrastructure. And of course, we need that robust utility system. eVTOL, the battery-powered ones, they are going to require a lot of power, but there is mitigation which is available, and I would point you towards some of the NASA studies that I think were undertaken by Black and Veatch, and there's lots of things that we can do to try and mitigate that. And of course, airspace. It's not built infrastructure, but it is designed and it does have a finite capacity. So our ability to deliver a valuable system really depends on making the best use of all these things. So the challenges, space. Adam talked a little bit about the footprints of vehicles, and it's really about the size of those vehicles and the size of the passenger facilities. So that actually means that to get those commercial volumes that you need a reasonable level of space. Again, electricity, it is going to require recharging, so we need to address that. Public transport capacity, social acceptance, and zoning. And maybe I want to spend a bit of time on that, because I've seen a few presentations which talk about trying to identify specific zones, but the examples that I'm seeing of zones for urban air mobility seem to be co-located with industrial areas, but vertiports are trying to get people to where they actually want to go. And since those industrial zones are relatively low in terms of the number of people occupying that space, it's not necessarily where you want to put a vertiport. We need to identify those areas where it's beneficial to the makeup of the city. So the example I want to take you through is something called the Waterloo Vertiport. And I developed this with architects in London called Pascal and Watson and AIQ Consultancy, who do a lot of process consultancy in the aviation industry. So of course we started with the top-down view, looking at the airspace, and what you're seeing is Heathrow there, and on the right the city of London and the various different heliport routes. But of course electric aircraft will be able to potentially open up new routes for these aircraft to operate. But then looking a little bit closer at London, so we have the London Underground system, and we have these terminus stations dotted around London. So the question is, how does a vertiport at any one point in the city redistribute some of the traffic that will be coming into those terminus train stations and using the underground system to go somewhere? So looking at that, I've identified several different sites for potential vertiports, and they're all near areas either where you're able to fly along the Thames in the existing helicopter routes, or they have a good intersection with the underground system to try and deliver passengers to where they really want to go. And that's a lot about what the Waterloo concept is about. So here we have a kind of an exploded view of the vertiport. You have the airfield in red, the passenger facilities in yellow, the gray vertical circulation to get people above a mixed-use building. Of course, we have the Thames River to the north for water taxi, and then we have this Interchange Plaza just to the south. And really the whole concept was built around this Interchange Plaza, because what we're trying to do is encourage as many passengers as possible to arrive at and leave the vertiport via public modes of transport. So we have a natural connection to the underground station at Waterloo, where we have the rail, coach and taxi type operations, a tram, and then of course we have the river bus itself. And one of the concepts that I'm working on with a group of companies here in the UK is something called the Vertiport City. And what we're going to explore is how large vertiports can actually start to change the fabric of the area around that vertiport, and what possible changes you might need in terms of planning policy to support that and make the best use of that type of development. So here we have the actual location itself. The site won't be developed. It's actually a listed building, but it was a thought exercise, and just to the south, Waterloo station. And this exercise here was really talking about how far could you actually get with your Mark 1 feet. So the green area that we have shaded there is actually about what you can do within about 10 minutes of walking. And the yellow shaded area is actually what you can do with about 10 minutes of micro mobility. So it really goes to show you that a well-located facility can access quite a large area. Now, of course, in London, because of the Thames, we're separating the north and south a little bit, so there's a bit of a skewness to the south, but you can address that. But of course, Waterloo Station is just to the south of the Vertiport site, and there we have the Jubilee Northern and Bakerloo line, and we've also suggested a river bus. So in this exercise, we identified the area that you could access if you just did 2 tube stops and walked for 10 minutes. So all of a sudden, your ability to access a large part of London becomes real. And of course, if we take that a little bit further, if you do those 2 tube stops and 10 minutes of micro mobility, then all of a sudden you're able to access a significant area. And the radius of that is about 3.5 to 4 kilometers. So we're really in that micro mobility area where we're able to try and get passengers onto public modes of transport or micro mobility. So we got some examples here from Uber 2018, the 2 on the left versus Uber 2019. And just to put it in context, the one on the bottom left, that Vertiport has a capacity of 10,000 passengers per hour. And they do that on 3.5 acres of land. Now, to really put it in context, LAX does about 20,000 passengers per hour on 3,500 acres of land. So you could imagine what would happen if that were to be approved and built without any due consideration to the ground transportation or the public transportation. You would literally have chaos on the ground. Everything would be flying, but you just wouldn't be able to get everywhere. On the right, the concepts were about the conversion of car parks, which create their own challenges. The Waterloo concept that we presented can do about 4.3 million passengers per annum, and I'd suggest that we have probably about 3.5 million passengers per annum for these facilities. And what you're seeing is that they have huge amounts of curbside frontage for drop-off and pickup of passengers, but just eyeballing it, I would suggest that there's not enough curb frontage. So you could imagine how many car journeys are going to be generated from those facilities unless they're co-located with public transportation modes. So just recapping, we really need to go back to that aviation system planning. So I'd really suggest that you look at what a study would look like to have a better understanding of how electric aviation can fit into your region. Whoever is submitting planning applications, they need to have a good understanding of the local transportation policy. They need to understand what it means on the transportation network, and it needs to complement, not compete with that public transportation, because really we are trying to drive people onto their feet or micro modes of mobility or public transportation between 1 and 3 miles. And of course, what we really need to see is that they address social inequalities, and they can do that through supporting local job opportunities. And this is what I'm hoping that we'll see come out of this Vertiport City concept that we're working on. So I'm going to stop there, and I believe that I'm passing back to Yulenka control.
Actually, Daryl, you're passing directly to presenter to Basil.
Oh, right. Okay, there we go. We'll get that right. There we go. I think I've handed it over.
You have, great. So hopefully everyone can hear me and see my screen now. Excited to be here, and thank you for the invitation from APA to speak. And I just want to say this is really an all-star cast that you put together around UAM and AAM. And I don't say that because I'm part of it, but because I've known and worked with these individuals, and you can see by the content, there's a lot of great content that you're learning here. And so my portion of kind of this time together is around understanding airspace considerations. So let's jump into airspace, what's going on above our heads, and how can we learn from the past and apply it to the future. So let's talk about airspace in urban and suburban environments. And I have what's called a sectional chart up here of New York City, and it looks like a mess. We have all these different things that are going on when it comes to aviation in the New York corridor. And as you know, there's multiple airports. We have heliports. We have lots of traffic, lots of different types of traffic. And so it's not total chaos. There is some structure to it, and the structure and chaos, or the structure has been put in place over years and years of planning by air traffic control and lessons learned. And I think if we can understand how, kind of the existing airspace works, the rules that we have, how we're moving people in packages right now with manned aircraft, there are lessons that we've learned that can be applied to this new space, this new low altitude UAM or AAM environment. And so we'll talk about the different types of airspace in a second, but we just want to note, so this picture you see here, of course, is downtown New York. And if I go to the next picture here, these are the helicopter routes that are in New York as well. And so in the very simplest kind of terms, we have fast-moving aircraft and we have slower-moving aircraft. The fast-moving aircraft being our fixed-wing aircraft that may be transitioning out of New York overseas, or they may be just going to another state or maybe even within New York State. And so then we also have helicopter traffic, whether that's news, with medevac, VIP movement. We have tours going on in New York, and they're slower moving at kind of a lower altitude. And so we can segregate these operations, of course, just by altitude. In talking with air traffic controllers, just for example, in some cities in North Carolina, we're really looking at the tallest building that there is in a city, and you're going to keep your fast moving traffic above that tallest building, and you're going to keep your slower moving traffic below that tallest building, and so at lower altitudes. And you're going to utilize, some of the geographical features that you have as well. You're going to be moving, like helicopter routes are often over, in this case in New York, we're moving over water, right? We're not moving between buildings, but we're moving over those open waterways. In some of those locations where the helipads are on the water. And so that allows for an easier transition in and out. And you can think of the population density and noise, other factors that it's helpful to move people or goods via helicopter over water. And I use helicopter as an example. Our next presenter is a helicopter pilot, so I don't want to steal too much of his thunder. But it is very similar in some ways to what AAM is going to serve as well, right? It's a different type of aircraft in the sense of the power plant, but it has similar features as well, except for the automation part that is a big part of UAM and AAM in the future. So let's talk a little bit about airspace, and I think my primary takeaway I want for you to understand from just this slide in airspace is that all airspace above you in the U.S. is regulated, and not all of that airspace is controlled, meaning we have classes of airspace where if you're flying within that area, you are under the control of an air traffic controller. We have other airspace that is called Class G airspace. It's called uncontrolled airspace. there are regulations for you to be in that airspace, but it's uncontrolled. And I think that's an important distinction, because uncontrolled airspace, the pilot has the discretion on where to fly, versus controlled airspace, where the air traffic control guides and directs aircraft through the airspace to and from their origin or destination, which is often airports or heliports. And in a lot of our urban environments, we have our larger airports, because airports are close to their customer. And so lots of times there's potential for overlap of the controlled airspace into these urban environments. And so again, that's important, because controllers are often going to use defined routes, like routine routes, whether the runway ends are driven by winds. So there are going to be kind of standard approach and departure routes into our airports. But there are also kind of standard routes that you're going to have just for moving both helicopter and manned traffic. And when those changes are made to those standard kind of approach and departure paths, we have often seen communities very vocal about those changes. You can imagine buying a house in a neighborhood where you have little to no traffic, and suddenly there's a change, and now air traffic control is routing traffic over you. And so there already is built in a process, a NEPA process, where you engage the community on the feedback for those new routes. And this is important, because these same rules that are in place around kind of new routes in the sky are going to apply to the future corridors that we will see UAM and AAM, essentially these electrical VTOL air taxi operators in. And so that takes me to kind of some documentation that NASA has put together, which I think would be a great resource for you if you're interested, certainly in this space. But FAA and NASA have worked closely together to publish what's called an Urban Air Mobility Concept of Operation. And this is a very new publication. You can see there back in June it was released. And again, this is a collaboration of work that's been completed by both FAA, which is our Federal Aviation Administration, has oversight of the airspace, NASA, which is, as you know, a very robust research organization, and they have a wide breadth that they're looking at, all things aeronautic. We often think of them as space, and putting folks on the moon or the space shuttle, but they do a lot of work on the air traffic side and enabling these different technologies that we utilize and take for granted and how we move manned and commercial aircraft right now. And so when you read through this document, one thing to keep in mind, and this is in the introduction, this is just the initial kind of framework that's being proposed. And there'll be many iterations of this concept of operation. And it'll be important to be part of that conversation as planners, because obviously there's a very important role, as has been noted before by our presenters, and I'll note here later. And so this is a familiar picture, which you've seen. Adam showed this earlier. And this is important to understand that what FAA and NASA are proposing is corridors. So we talked about these different classes of airspace earlier. So we have, a Class B airspace, or C, which means it's under the control of a air traffic control. And so all of those operations are kind of being guided in those areas around, by those air traffic controllers. And the idea is that in those areas, there would be defined corridors. There'd be defined routes between these vertiports. And that helps, one, take the workload off of the air traffic controller, because he has kind of a defined route of where he knows an aircraft, an expectation of where that aircraft should be flying. And when I speak of aircraft, I speak of the eVTOL or air taxi. But then there also will be corridors in kind of the Class G airspace. That's the uncontrolled, right, where the pilot has the discretion on where they go. And it's important to have corridors there, because it gives those pilots that are out flying an understanding of where to expect these UAM and AAM operations to take place. So knowing where individuals are flying through a corridor is a step in helping safely integrate those operations into our airspace. However, it's actually very helpful for planners as well, because now you know where those operations will take place. And this is another graphic from that same document I mentioned. And so what this is illustrating is, in the beginning, the operations will take place in kind of point-to-point trips. There'll be a network of point-to-point known vertiport locations. And I think if we think about how we have built highways over the years, right, they're feeding large areas. When we build bus or metro routes, as highlighted earlier by Daryl, we're again meeting the need of the population user and trying to engage the highest density of folks. But this is different. And so if you think about the metro and bus, right, those are scheduled routes. But this is a bit different because this is going to be point-to-point routes in the beginning, and it's going to be driven by demand. And so we have heard already from our presenters that those vertiport locations will be driven by a lot of different things, right? There's the connectivity, which is a key part of those locations. But in the beginning, it'll be known routes between these specific locations that will start appearing in both our urban and suburban areas. And so if we take both of those, those two concepts, right, the corridors and understanding where those vertiports are, it's very helpful for then planners to think about the impacts to their community or how they want to integrate those into the existing transportation system. And so let's think about our existing airport infrastructure and what are the protections that planners have used or tools that they've had to use in the past. So we have seen, of course, zoning. Zoning protects the investment that's been in that infrastructure. A lot of the publicly owned airports have lots of taxpayer dollars tied up in that infrastructure, that land, and the ability for those operations to continue. And so when you can place these zoning restrictions in place, you're doing really kind of two things. One, you're ensuring that there's not going to be any future airspace hazards. In the most simplest term, no one's going to build a 70-story tower at the end of the runway because it's off airport property, because you have some zoning restrictions in place on those building heights, and that protects, again, that investment that has been made and protects the traveling public. But you also are going to have noise impacts, and so you want to make sure that there's compatible land use around our larger airports. And so these are things to think about as we begin to understand these same impacts, both the flight profiles in and out of vertiports, as well as noise in our communities. And there's kind of two layers here. We have the airspace, which is part of the federal jurisdiction. There are rules about building, over a certain distance from the ground. If you build over 200 feet, you have to submit a 7460, which is a process to get an airspace study by the federal government. But at the local level, the tools and authority are really in zoning and land use. And so what I did here was I pulled together a lot of different states have these kind of model zoning acts or authority that has been codified in law. And in this particular case, I just pulled up Ohio, and there's a whole section, and I didn't even include all the different sections, but there is protections in place, again, to protect both the state taxpayer dollar and the federal taxpayer dollar in these infrastructures. And that will be important to apply to the vertiports of the future as well, right? If we are going to invest in our community and the locations of these vertiports, we want to make sure that they are in advantageous locations and that we're protecting the area around them. So if we find, and again, these vertiports are driven by demand and by customer demand and connectivity. If we site a vertiport, we want to ensure that the aircraft that can get in there and out of there safely. So there may be some zoning or height limitations that will need to be in place. And then, of course, as we think of the routes, there want to be, understanding that close dialogue between the corridor development and the impacts of the population under it. So if potentially, if you could route these operations over, industrial areas or areas that already have high noise profiles versus residential, that the community will be able to accept these type of operations. And so what we've learned from in the past is that there are concerns around noise. There's concerns around congestion, visual pollution, seeing those operations take place. So traffic and frequency. There's security and privacy concerns. We think about these new aircraft operating at lower altitudes, and so there could be a concern about now someone in an air taxi is flying over my backyard or an area that I have that in the past I felt I had a reasonable expectation of privacy. And so these are all concerns that we've seen in the past when it has come to manned aircraft, and I think certainly items that will need to be addressed as we think of unmanned and AAM. And so this is my last slide, but we've learned a lot over the years of having airports and heliports in our communities, and we want to use those experience and tools from the past and apply them to the future. And I would close with the fact that really enabling these type of operations is going to involve planners and transportation agencies to be in the discussion. And right now we're seeing lots of investment in urban air mobility. And at the national level, the dialogue is often associated with the federal regulators, NASA, and manufacturers. And so the purpose of really CAMI and the discussions we're having now is to let folks know it is important to be part of that conversation, to be part of how we can safely integrate it. We know planners will be involved in it, and so being involved in those discussions early is going to be critical. So we would encourage you to continue to pursue and educate yourself around UAM operations. And with that, I will turn this over to Todd Peterson.
Hey, Todd, are you with us? There you are. Okay.
I am here. I'm just
good. Thank you.
Shuffling around. Can you guys see my screen okay, I assume? Great. Excellent.
Yeah, it looks great.
Excellent. So, hey, thank you so much. What a great opportunity to be here with all of you and the panelists, and to get to talk about this subject. It is a privilege for me. I think we've heard from some great presenters, and what I've recognized is that this is a blend, right, of what we've seen from the best of planners on the ground, from Adam, and also what's really going on with planners from aviation. And so it's an exciting time, I think, for all of us to be able to combine these two worlds together and all for the betterment of society. So it's a momentous time that I think we should all reflect on and be excited about, or at least I am. So I'm going to talk to you about integration, and I'm going to start with our story of where we started all of this, in going back to the dawn of the jet age and when cities were coming into their own. And as respecting sort of that combination of the best in city planning, where the city planners are used to seeing a world like this, right, where we see interstate freeways, and we see the benefits of being able to connect people from where they live to where they work, and what that means to opportunities. And also, I think it's important that we've learned a lot. We've learned what these decisions mean to society. We've been able to see the outcomes from them on the terrestrial side, on the surface side. And and how that they have negative consequences as well. And I think that that is all just incredible. It's an incredible journey that we've all been on from a planning point of view and in learning how to build cities in our world. And same goes for the airport side. I mean, we a rich history. I mean, I look at this picture and I can only imagine, you know, a farmer and a young aviation executive from the FAA and maybe a mayor, and those talking about possibilities and talking about airport and being able to really think about things from a green field kind of perspective. But you know, obviously those days are behind us, and we're dealing now with this, right? We're dealing with a fully built environment. We're dealing with future decisions that obviously need to be made, but a lot of those decisions come with trade-offs. They come with difficult, they're difficult problems, and the solutions are difficult as well, and it's going to require a lot of work on all of our parts. And we're still left with these sort of problems, right? In Los Angeles, you can still reach 12 times as many jobs in an hour by car as you can by transit. And so I think UAM in some respects offers a solution to that. You know, other challenges that we still have, I know in California that the leading cause of fatalities among children is vehicle accidents. Like we really just need to, it would be great to not have to deal with that anymore, right? It would be great to have alternatives. And I think UAM represents one of those alternatives. And many of you who are maybe on the city side of this is how you think about airports today, and it really has to do with like a built infrastructure and taking what we already have and sort of molding that into what's needed in the future by expanding or trading off spaces one for another, and doing that in conjunction with our counterparts at the federal level. But now it's different. UAM is changing and disrupting a lot of our jobs, is disrupting a lot about what we do and how we express ourselves and the considerations. And I imagine some of you might be listening to all of this and the complexity and grabbing your retirement calendars and starting to do triangulate the math. But I'm here hopefully to help you understand that that this is actually not as, this is a great opportunity, and it's an opportunity to work together and figure this out. So I know many of you are maybe thinking, as you heard all of this, especially those that are on the airport planning side of this, from Daryl, Basil, and Alex, you know, you're maybe wondering from a surface transportation point of view, what is my role in all of this? Do I need to learn how to be an airport planner, or maybe do I need to have an airport planner on my team? And so those are valid questions, and I think that we're in the process of answering those questions. And a lot of it has to do with what happens when the entire city is an airport. I mean, I think you saw a lot of really thoughtful pictures and architectures about what mobility looks like when you're moving people. But as we start to think about the freight part of this as well, delivering packages with unmanned drones, which might in some respects maybe sooner than we think, the whole city literally could be an airport. And it starts to bring up a lot of questions. There's also a lot of diversity. Like there's, I think in the chat here, I think what 321 vehicles in the concept phase right now from Daryl in the chat. That's incredible. That's an amazing amount of diversity compared to what we have today, which is, you know, essentially one or two designs that we've honed in on. And as you look at this list in the broader list of 321, every one of those vehicles has a different approach. They have different performance characteristics, different capabilities. They have different noise profiles. They have different impacts. And we need a way of really simplifying this in a way that we're not picking winners and losers of vehicle designs, but we are able to identify them and classify them by their impacts, by maybe their urban impacts. So what I want to talk a little bit about is what is the role of a city planner now, whether that planner has a background in aviation or terrestrial or surface transportation. What exactly are the sort of decisions we're faced with? And I think one of those is what is an airport exactly? You know, is it what Daryl showed, and maybe what Uber's thinking it is, which is a multi-pad, multi-port, where there's a lot of concentration and a lot of egress and ingress and a lot of curb challenges, or is it a pad that's not far from your house, or at your house for that matter, if you're going to have a package delivered. So I think we have to think about the whole city as an airport, and really start to identify and think about and answer the question of what is an airport. Also, many of you might be looking at this through different lenses, and you're wondering, like, what am I really solving for here? Am I solving for safety, or am I solving for an equity outcome, a noise impact outcome, a pollution environmental outcome? Like, what exactly? How do I solve this problem? There seems to be a lot of variables, and on top of the variables many planners have to deal with and contend with every day now, which probably seems overwhelming. Also, how do I express these desires in my changes? If I decide I want an airport here, what does that really mean? And how do I express that? Who do I tell? How does that interface with the role of the FAA or operators? And then, you know, if I'm doing all these jobs, what is my role within a larger context? So these are one of 4 of probably dozens of questions you're thinking about as you hear all of this. And they're all correct. We are figuring it out. But the good news is I think from a city planning role, the best thing we can do is think about UAM as just another mode of transportation. I think that's the good news story in all of this, is that at the end of the day, even though there's a lot of interesting things happening, I think from a city planning point of view, we can consider it as just another mode. How do we integrate that mode into our city in a way that enables the outcomes that we all care about? And if we demystify it and simplify it as that, I think it's a good place to start. So what I'm going to go over is a little bit about like how we would think about it, maybe as terrestrial planners, from a terrestrial planner point of view. How would we think about integrating this into our society today and expressing ourselves as planners? Many of you are going to start this conversation with different points of view, so I'll just name a few here, but not trying to exclude intentionally anybody's particular different point of view or how they think about it. But one of the ways that we could is we start with a map that looks like this, right? This happens to be Los Angeles. It's a map of where all the noise is, and there is one of these maps for every city in the planet. And we see if we're solving for noise, where is the noise at? Well, it's at airports right now. And as we contemplate thinking about the city as an entire airport, where do we allow these things to land with that? Some of you might want to put it here, right, in the quiet areas, or maybe in the noisy areas, or not. You know, maybe we're not even thinking that way. Maybe we're thinking differently, like this is a social equity map, and maybe we're going to make sure that we place aircraft in facilities in areas where they're underserved. And maybe some of you are grabbing your old tried and true zoning maps, and you're thinking about how to contextualize the placement of UAM facilities within those contexts. You know, in talking about light industrial, talking about residential, and some of the terminology that we've used in the past. So I don't think there's any one approach on how you actually do this, but there is some opportunities, I think, and what's being discussed is how do we express ourselves when we actually decide, and what's really important. So there's a lot of people thinking about that, including NASA. There's some conversations going on around tooling. How do we help these policymakers like yourselves make decisions? And as you can imagine, there's many layers to this problem. And so NASA's done some work in trying to help facilitate that, and with different overlayments, whether that be where the electrical grid capacity is, where the people are living, where they're working, social economic layers, as you can imagine, the list goes on. But at the end of the day, what are the decisions that need to be made, and how do we express them? So the first one, first and foremost, is where they exist, and I think that's probably the most straightforward. And we can probably imagine that today if we just consider it to be another mode and do the problem solving like we would do a transit station. Except in this case, you're not really responsible for the tube or the tracks. You're only responsible necessarily for the stations, or the vertiports in this case. So that's number one. Number two is what you kind of see here, and it's represented conceptually in this code, A15E10. This is something that is being discussed right now at NASA within the national campaign with the firm that I'm with, and also Los Angeles. And we're starting to think about other things that really are part of the context of UAM, but not traditionally something you'd have to consider. So one of them might be a vehicle classification system. So what if we had the ability to classify these different vehicles, that diverse list of 321 vehicles, into classes based on their impacts, based on their noise characteristics? And where like one classification would be just something we could relate to, like a very quiet vehicle, and maybe on the other end of that classification system is something that we have today in an open tail rotor helicopter or something like that. What if we were able to determine what the weight of the vehicles was able to be, not necessarily from a safety point of view and what the vertiport could carry, not a structural type of question, but a question around what kind of vegetation is in that area. If you think about the physics problem of actually displacing or elevating an aircraft into the air, it creates wind that is actually equal to the force is equal to the force of the weight of the vehicle. So do we want heavy vehicles landing in sensitive areas, and how do we determine that? Same goes for the energy class. I think many of us are assuming that all of these are electric. There are many hybrid designs out there in that list of 321. So I think that we would classify these vehicles based on energy, and then also, last but not least, frequency. How often, how many, if there were 10 landings an hour versus 1 landing an hour, that makes a big difference to the impacts on the ground. And then more importantly, how do we get through, how do we convey those desires of ours from doing the work that we do in the public engagement and outreach, and expressing that policy that we would have, those decisions we just made. And so we're thinking deeply about that as well in terms of what the land use policy looks like specifically, but also what a permitting framework might look like, and what kind of digital tooling is required in order to maybe communicate that policy, and also regulate the vehicles themselves in helping to integrate last mile solutions. So really it comes down to there's a need for a lot of digital policy tools, not only to make the policies, but to the tooling as well to convey them. So we're not unintentionally creating a patchwork of regulations from city to city and forcing the stakeholders on each city to integrate differently. So there are organizations out that are figuring this out right now. One example is in the Open Mobility Foundation. Also, CAMI's hosting the UAPC as well. So there's plenty of places to get engaged and start to talk about these depending on your level of interest. And then at the end of the day, I just wanted to kind of humanize this and show you how it might work or feel for a person like yourselves, or either you as a consumer or you as a city planner. And so we go through this example where Ayana, this fictitious person, is shopping for something online, and the retailer is able to fulfill that order and contacts a shipper that notifies that there's a need for an aircraft, a shipment. The shipper knows that a Class A vehicle is needed, and to arrive at a particular destination where Ayana once the package delivered. And that's all being done, that operations being done under the oversight of the FAA, and who is monitoring the route and making sure that we are fulfilling our safety obligations. But parallel to that, importantly for you as planners, you're creating policy that allows that flight to happen in the first place, that informs the shipper whether a Class A vehicle is needed or a Class C for that matter, or a Class whatever. And so that policy is being developed sort of ahead of time or in parallel. And it's a reflection of maybe what your leadership wants and has been doing to invest in UAM infrastructure. And at the end of the day, what we're really focused on is the outcome. And the outcome is that a package arrives at a location, or a human being for that matter. And at the end of the day, the shipper was able to deliver that package. And the city was ensured that the package arrived not only safely, but also without disrupting neighbors. And so this is sort of the construct and animates what we've been thinking a role is for the city, for a city planner like yourself. I'm just going to leave you with a few things here. I think what you've heard today is that it was a lot of different perspectives, but the biggest thing to take away is that this future is very much in development still, and you're right on time, you're not late. And if you want to get engaged, there's a lot of opportunities, and I encourage you to reach out to Yolanda to get engaged if you're interested, or your APA, local APA office. Also, key to this is collaboration and community engagement. It is really important that we do that well. It has been identified at the federal level as one of the biggest risks to UAM being real. And you all have a lot of experience with that. So the FAA and NASA and others internationally are looking for feedback. They're looking for their engagements, and they want to hear from you. So get involved. And then also technology can be the unifier, can be the catalyst, and that helps us make sure that we're not creating a patchwork of regulations, and that this could really be a sustainable form of transportation for all stakeholders. And I will leave you all with that, and I will hand this back to Yolanda. I think we're a little over time, but that is what happens when it's super interesting and fun. Let me see here, and I will hand back to change presenter. Look.
All right, hopefully you can hear my voice in just a second. I'll have my screen back up. Let's see here. Hopefully you can see that screen. So I just have a few last minute comments. So again, thank you so much. I'm sorry that we've run out of time. Let me just run through a few resources here. So while we are relatively young, we've achieved at CAMI a lot in the past year. So you can go to our website, which is communityairmobility.org. And you'll find our growing set of resources, including the videos from our UAM 101 virtual half-day event last spring, our library of CAMI notes, and our upcoming guidebook for cities. We add resources all the time, so please come back, check back often. In addition to those online resources, we do a lot of presentations to symposia, conferences, webinars like this, and participate with a wide selection of industry groups. So we do new webinars and target specific audiences like this one for planners. We are also available to meet with state and local decision makers, airports, transportation departments, and planners to do presentations, develop and implement community engagement plans, or work with you to address the specifics of your community. On behalf of CAMI, thank you for listening. A huge thank you to all of our presenters and to the APA for hosting us. Please visit our website, consider joining us as a member, and we look forward to connecting with you. And finally, here, I'll leave this up. Here is the contact information for all of the presenters. You can reach any of them through me. I will make sure to connect you with them if you don't capture everybody here. I also will tell you that because we're out of Q&A time, APA Ohio will send us the list of questions, and we will respond to those and give them back to APA Ohio to post or to distribute. They've got the distribution list. So I do apologize that we ran over, but I hope that this has given you some good information and inspiration to join in this industry and to learn some more and to work with us. We really need planners involved in this conversation. And with that, I will turn it back over to.
Thank you. Yeah, and just real quickly, when I send those questions over, I'm going to have you respond directly to the folks that are asking them. I'm not going to post them back again. So just as a reminder, also, we are recording this session and it will be available on our YouTube channel. Just search Planning Webcast on YouTube, and we will have a PDF copy of the slide deck available on our GoToWebinar, on our webcast webpage, ohioplanning.org/planningwebcast. So thank you everyone for joining us today. We appreciate your time talking about this unique topic to planners, I think. And everyone have a great weekend, and we'll talk soon. Bye-bye.